Okay, let me explain my code here. In this week's assignment, I created a new class sorting tree, which inherits from the binary tree. Here I didn't use any, I didn't declare any private attributes. I just call the constructor of the parent class. And here I use this warning simply filter to ignore the warnings because later I will visit many nodes which doesn't have the left child or right child. It will raise this warning. I don't want too many warnings. And my first method is insert. This insert given a single numerical value, which is the input value is this num number, and insert this value as a node in a binary tree, such that every node in the left tree is less than or equal to the node, and every node in the right is greater than the tree. According to the requirement, I need to use recursion here. Firstly, I just handle the exceptions for the input value that is not integer. And I firstly determine whether the current node is none. If the default value is none, if the user didn't input any value for this current, then it's none, which means it starts at the root node. Here, the get node function, if get node method is from the binary tree, which is also from the versatile. It's a superclass of the superclass, which means get the nodes in the tree. So the index 0 means it's the first element. First element is the root node. And here I have two base case for the recursion and two recursive case for the recursion. The first base case is the number is less than or equal to the current node, and the current node does not have the left child. It will like this. If the current node is 2 and say the number is 1 and the 2 doesn't have the left child, it will add node left. It will add the left child to this 2 node. And then I will because it has already um, insert a node to the left of 2, then I will initialize the current as none. So the next time it will also insert from the root node from 4. And the second base case is almost the same. Is find the parent node and add the number as its right child like this. If this 7, if 7 is greater than 6, and if 6 doesn't have the right child, then it will insert 7 to the right of the 6. And recursive case is when search when search the valid parent node to the left down, like in this 4. Say 1, when at this root node, if 1 is less than or equal to 4, but the 4 has already the left child, then for the else is statement, uh, it will call the insert function itself. It will call itself, and firstly, it will reset the current node from this node to its left node, and then it will call this function itself. It will conduct the recursion, and the number itself and the current node now it shifted to the left child to the previous node, and for another recursive basis, almost the same. Is just search the node right down to the right down. If seven, if it is in this node, but this node has already had the red child, then it will shift the current node to 6, and it will call the function itself. It will conduct recursion to use this 6 as input and execute the function the method itself. So this is meaning for the insert function, insert method. And the other one is traverse, is to return a sorted list to the values of the tree. For this kind of insert, whose left subtree is less or equal to the root, and the right subtree is greater than the root, we can just use the in order traversal to get the sorted list. Here I have um, a stack to store the elements, and I use an inner function. The outer function provide a stack a list to store the the return value from the return value of the inner function. For the inner function, first, I also determine the node whether it is none. If it is none, means it will start at the root node. And there are two recursive case and one base case. The base case is that um, the left node, the base case is when this if doesn't hold, means the left node of the current node does not have the left child, and in that case, the base case will be executed like for this graph. If the left node, if for 2, if it doesn't have the left child, then the 2 will be added to this stack. This element will be added to this stack. And the first recursive case is to determine whether the current node has a left child. If it has a left child, it also calls the function itself to get the left child of this current child. So here I don't need to shift the current node. I just use this recursion to call itself. When call itself, the input value is the left child of this current child. So it also the 2. When the node is 4, then get its left child is 2, and I use this 2 as input value of the function itself. So it will visit this 2 node. And the second recursive case is get a red node. So I want to visit the right node after this 2 part. If it doesn't have the left child, and it the child itself has already added to the stack, then I will visit the red child. After the 2 is added to the stack, I will visit the red child 3, and if the 3 has neither left child has no left child, I will add 3. If the 3 has red child, I will add the red child of 3. So the basic order is left, and the parent, and the right. And after these 3 are all visited, we can treat this 2 as the left child of this 4. So this 2 is visited in the 4, and I will visit the red tree. So for the red tree, this is a parent, this is the left, and this is red, and I visited 5, 6, and 7. The in order traverse is like this. And then after I define the inner function, I will call the inner function and add the value returned by inner function to the stack and return the stack. Okay, now let me execute my code. Um, the requirement is to use this list of numbers. The first element is 6. It is the root node. And then I insert others. So here I use the 6 for the sorting true, for the root node of sorting tree. And I insert others with this loop iteration. And now let's see the binary tree. Let's see if the for all the left subtree, it is less than or equal to the parent node, and for the red tree, it is red subtree. It is greater than the parent, and then I will the sort the nodes in the tree with this traverse function. Let's say you can see that 0, 2, 3, 3, 4, 6, 7, 12, 24, 63 is it's just sorted list. Okay, and this is my assignment